we have established a leadership position with some technology and some innovation. However, everybody's copying us and knocking off our solution and really trying to do the same things that we've done. And so there are products out there now that are similar to different bits and pieces of our solution. So the one thing that we need to rely on that differentiates us from everybody else is the fact that y'all are smarter than their guys. That's the one place where we can play. And so my job is to help you get there to deliver that. How important that is here, real quickly. I'm getting out of 101, Michelle.
Don't go too far, Ian. I don't want to see the formulas up on the board. Being subscripts or coefficients.
Okay. This is going to be a 30-second course in fan affinity law. All right. There's fans have revolutions per minute. All right. How many times fan turns around? There's a 1-to-1 relationship between fan RPMs and the amount of air that comes out. So when the fan's turning 100%, it's producing 100% of its capacity. When the fan's turning at 80% RPMs, it's producing 80% of its capacity and flow. However, the energy required to produce that RPMs is the cube of the proportion.
I was with him until that cube.
Yeah. Well, all right. Let me. So we got to when the fan's at 80% of speed, it's producing 80% of air. So we're at 80% RPM. So we're going to cube that because that's our proportion of capacity. So we take 0.8 times 0.8 times 0.8, and that's 0.512. Basically 50%, right? So if we're running 80% fan speed, we're only consuming 50% of the energy. All right? So when we talk to the customers about on bullet number 3 here, their fan savings, it's not a 1-to-1 deal. If we get them 20% savings on the air they need, they get a 50% savings on the energy, assuming they're using air handlers that have variable frequency drives or EC motors on their fans. If they're using really old equipment, they won't get this. The only benefit they'll get is being able to turn one off. All right?